again, Andrea, and the floor is yours.
Thank you. Thank you so much. I'm really pleased and honored to be here today and have the chance to meet you all, because I think this is very important. So what you see at my back is the internal part of Sesame. So the machine is under those blocks of concrete, and but if I may share my screen, I could quickly have you have a look also at. I guess you all see my screen now, yeah. So this is how it looks outside. So it's a rather large building in the wonderful hills northwest of Amman in Jordan, and its symbol is a circle, because you know all synchrotrons are made in this way. You need space in order to accelerate the electrons, so you make them turn a lot of times around as a closed circuit. And in this way, it is also a very economical way to put many instruments around. So it's inherently, also geometrically, a place of cooperation. You stay sort of around the round table and share the same source for many different possible scientific endeavors. So just to update you, because we sort of disappeared from, we were very young before my arrival. We were very young. We were just opened in 2018. The first beam lines were opened. And the first 50, 60, 70 scientists started to come and make experiments to the, at that time, 2 beamlines open. And then COVID happened, and I arrived more or less at the same time. So I hope it's not bad luck. I didn't do anything, I promise. And then we started, after lockdown, we started reopening the machine, but for mail-in. Experiments. People had to send us the samples, and we were measuring them with some tools like WebEx or Zoom, and interacting with them, and no machine that allows the users from outside to control remotely experiments. All this is very good in times of emergency, but clearly it is not the way we were meant to work from the beginning. It has been, in my opinion, a bit of a hiatus now in the development of the machine. But we did not stay still. During COVID, we were still able to open a 3rd beamline. So in December 2019, you see here this big instrument. The powder diffraction beamline entered into operation and started hosting users, initially from Jordan, and then with mail-in. And many experiments have been done and published during this time. You know that this is the life of researchers. You do your experiment, and then you need time to elaborate the data and to make write the article. So that time was well used also during the COVID. The peer reviewers are always active, also during a pandemic, and papers keep coming out. And so this was done both in the IR spectrum, so with the IR beamline for, let's say, chemical fingerprints of objects, as well as for fluorescence and diffraction and EXAFs, these latter two for discovering where atoms are in a sample. And as you can see here, the baseline of papers coming out of a facility like this changes completely in the moment you turn on the machine. So before 2018, a few papers describing the beamlines or doing some experiments in infrared with the laboratory equipment were published. And then in 2018, you switch the machine on and hey up, the number of relevant papers skyrockets immediately with a very encouraging pace. We are still building more instruments. So in 2022, next year, we will open 2 new beamlines, 2 major endeavors of Sesame and of our friends, especially in Europe. This is the BEATS beamline, where you will be able to conduct computer tomography experiments with an, let's say, unparalleled resolution with respect to what you can do with a laboratory source. And the HAZEP machine will also enter into operation, and this will be the first soft X-rays beamline that will be used at the beginning essentially for fluorescence measurements. So you will get access to the L edges of all materials, which will give you a very good insight of chemicals on surfaces, which is very useful for both technological and cultural heritage efforts. And after a while, the so-called Texpus branch line will be added. This is the 6th beamline, which will be available more or less in 2023, early 2024, and this is the first of a new model, let's say, a new business model of how you provide beamlines in Sesame. That is the possibility of having one member building an entire beamline. So Turkey will build a X-ray for photoelectron spectroscopy beamline out of this same source, which will provide the photons to the HAZEP beamlines. Now, how are we going on? First of all, we have to remember that essentially a synchrotron source is a community, is the community of its scientists and the community with its users. Well, so the first thing important is to get the people again to access the premises, and this is coming now. We are finally enough below restriction thresholds, and we are since 1 month starting to send letters of invitations for the users to come. It is a completely different and I would say more proper way of using Sesame. It must be a place where people meet, exchanges idea, learns new techniques, discusses new way of doing experiments, thanks to a machine which really gives an edge over what can be done in a laboratory. I would like to remember you that in terms of brilliance, the availability of energy, of photons, of number of intensity figures at a synchrotron are the most successful function that you can draw, actually, much better than the Moore's law in computer science. You know, that's if you plot one near the others, the increase of brilliance in these kind of machines is much steeper than Moore's law. Then we keep going in providing more and more instruments available for our users. But aside from strengthening the instruments which are available, we need also to strengthen the infrastructure for IT. We are, in a way, at the attached to the same community of synchrotrons, which is operating worldwide. And when the entire community moves towards the concept of fair data treatment, Sesame must do the same. So we must be prepared to go into a landscape in which you can essentially keep and reuse your data or anybody's data. So the FAIR stays for findability, accessibility, interoperability, and reusability. It's a fair concept, which means that the amount of effort put in taking measurements can be used and used again and used again more, but it requires a strong investment in IT, because otherwise it's not possible. Then, but this I just meant, I did already mention that we need to restart and support access in person. With this comes our need, not only the need, but it's also what we want to do, which is our mission, which is to have a closer interaction with the scientific institutions in the region. Starting from hosting users and moving to developing educational projects together. So places where a PhD can be made in collaboration with the university in the region. So the student could come here and live in this environment and participate of the life of Sesame and of the life of his or her university. And this will one of the best ways in my eyes to improve the effect of Sesame over the entire region. Then another thing that we must think of at Sesame is to keep our relations tight with the international societies and such as IAA, African Light Source, ESRF, the synchrotrons in Europe, LEAPS, the League of Synchrotrons in Europe, and so on and so forth. And we are pursuing actions after action in this direction. I just wanted to quote this one here because it's very imminent. So I suggest that some of you, I hope that some of you could send students to this. There will be a first ICTP school, so based virtually in Trieste on synchrotron radiation light sources, which we are organizing together jointly with IAA, ESRF, LAMP, the Initiative for Light Sources in Africa, Americas, and the Middle East, the African Light Source, and Sesame.
Dr.
Another
Andrea,
thing we should, 2 minutes.
Sorry for interrupting, yes.
Thank you.
Please.
So I'm finished. So the CH network, just wanted to discuss, this is a new concept that we would like to develop in the future, having the only synchrotron which is actually sitting at the center of the cradle of history. The amount of possibilities in archaeometry that we have in front is tremendous, and that could mark a specificity of Sesame for the future. Last and not least, Sesame can be a case study for the African Light Source. So I invite you to put your attention also on this joint conference, which will be hosted by ICTEX Lab in Benin, but it will be virtual in November, in which again Africa will interrogate itself about the possibility of building a light source for which Sesame can be both a case study, a training center, and a good partner. And with this, I salute you all, and instead of usual thank you, I'm looking forward to welcome you here. Thank you.